Most escape rooms start with a pre-game safety briefing telling you not to touch certain things or to stick your fingers in electrical sockets. And yet, if you ask a games master, they'll tell you that often players still try to do those things. It's like there's some kind of innate human desire to want to shove your fingers into places they're not meant to be. So, to quench that desire, I made this blender prop. And maybe there's a set of keys in it that you need to reach in and get. But when you put your hand inside, the blender turns on. Now, obviously, I haven't actually just videoed myself putting my hand in a blender. I'm not that desperate for YouTube views. This is totally safe, and I know it's totally safe, but the thing is, I'm genuinely still quite nervous to do this. And that just goes to show how much of a genuinely scary interaction this could be. And I think it could fit really well to shock players in a serial killer's lair style of escape room game. So let me show you how I made it. So I salvaged this blender from my local recycling centre where it was being thrown away for trash. It comes apart and I can lift the jug off. And if I turn that around, you'll be able to see here the blade at the bottom, which I can just turn by hand. Now, if I put the jug back on the base, I can turn it on and you'll see that blade spin round. So obviously the first thing we're going to have to do to make this safe is to get rid of that blade. Now to do that, I'm just going to reach in very carefully and unscrew this cog on the back. And if I can manage to screw that all the way off, I should then be able to just pull the blade out. There we go. And what's great about having done this is I've now got a hole at the bottom of the jug about 6mm across, which I can use to place a sensor in. And there's several different sensors I could have used, but I'm going to use a very simple, very cheap, light dependent resistor and just thread that into the hole until it pokes out into the bottom of the jug like this. And then I'm just going to fix that in place with some hot glue. So next we're going to look at the base. Now first of all I'm just going to unplug it before I unscrew it at all. And taking a look at this, I just need to take a work out how to open it up. So there are these rubber feet, and if I pull those off, yeah, there are screws underneath here. So I'm just going to remove those and open it up. And this is what you find inside. This is a 230 volt AC motor, but I'm going to replace it with this 12 volt DC motor instead. And because this only requires low voltage, it's much safer. So that's closed back up with a 12 volt power supply now, but the motor spindle's still stuck out the top, so I've just made this 3D printed cap just as an added precaution. And then we can put the jug back on to test it. So it spins and it rattles a bit, but there's absolutely no danger from any moving parts. Now we need to make the motor activate when players place their hand in the jug. So we've got our light dependent resistor at the bottom there, and I've threaded the cables out through that hole in the base of the jug where the blade was. That's my protected cap over the spindle end of the motor. And the sensor is wired to this ESP32 dev board, which also has built-in relay modules which control power to the motor. Now if I show you what happens when I place the keys in the jug, first of all, they go to the side and don't obscure the sensor. But when I put my hand in, that blocks the light entering the jug, which increases the resistance of the LDR. The ESP32 measures that resistance change on an analog input pin, and when it crosses a certain threshold, it activates the relay to supply power to the motor. So if you want to build this using a regular ESP32 dev board, the circuit would look like this. I've got my light dependent resistor and I've created a voltage divider circuit across that with a fixed 10 kilo ohm resistor here. Then I've connected one side of the resistor to 3.3 volts and the other side of the LDR to ground. Then I'm taking a signal reading at the point between them, and that's going to pin 33. Then over here I've got my relay module, which is going to be the output. That is controlled by a signal line sent on pin 15, And then I've got a 12 volt power supply, which the relay module is going to switch to the motor at the bottom here. And I've got a separate 5 volt power supply here, which is going to power the ESP32 and the relay module. But I'm actually using a board that has an ESP32 chip and some relay modules already installed. It's also got built-in pull-ups on the analog input, so you don't need to have that separate 10 kilo ohm resistor to create the divider circuit with the LDR. It's also got a power regulator and conditioning circuitry that means you can run it from the same 12 volt power supply as the motor. So that actually simplifies the wiring quite a bit down to this, but functionally it still works in exactly the same way. Now in terms of the code that's running on the ESP32, this might be the simplest sketch I've made yet. We set up the input, the LDR, and the output, the relay module, and then in the loop function we simply take an analog reading from the LDR. That's going to give us a value somewhere between 0 and 4095. Now when you put your hand into the blender jug, that reduces the light falling onto the LDR, which increases its resistance. This means that the voltage that we read at the analog pin goes up. When you remove your hand again, the light level increases and the value falls. So you could make a very simple implementation in a single line of code that just chooses a threshold value somewhere between 0 and 4095, and it switches the relay on or off depending on which side of that value the reading falls. The problem is that that value would fluctuate slightly. If you kind of held your hand slightly into the jar, the relay would click on and off rapidly as the value changed either side of the threshold point, which is not good mechanically for the context in the relay, and it's also not a good satisfying experience for the player. So instead I've defined two different cutoff points. It needs to rise above 2500 before we turn the motor on, but then the value needs to fall down below 2200 before we cut the motor off again. So there's a kind of a dead zone between these two values in the mid-range where the motor will not change. The reading needs to cross right over that dead zone and out the other side to change the state of the motor. Otherwise it's just going to remain in whatever state it's currently doing. And that's a useful little pattern to use whenever you have an analog input from a sensor, which you're then translating to control a digital output, which is either on or off. Now to determine the correct values to use there, you're going to have to do that empirically. So you might just want to add one more line of code here that simply prints out to the serial monitor what this value here is. And you can try it in different light levels just to get a value that reads correctly for you. And if you don't want to use a blender, there's plenty of other things you might want to discourage players from sticking their grubby little mitts into. Now here in the UK we don't have under-sink trash compactor units, but I've seen enough 1990s horror films to know that if I stick my fingers into the plug hole, that's going to happen. And this works in a very similar way to the blender. I've installed a fake trap into the sink here, and on the side here you see this little hole. This is where the sensor is. When that is blocked, the motor spins, and the motor has an offset weight, which is what causes it to vibrate. Or maybe there's some dangerous creature or monster inside a box that you need to reach into and placate. So that brings me to the end of this video on things that you shouldn't put your fingers into. Now I do just need to give an important safety notice. Obviously there are very good reasons why players in escape room games are discouraged from putting their fingers into certain things. If you have light sockets, electrical plugs, it's really important that players know what elements are part of the game world and what are genuinely dangerous to touch. So you do need to use this with some care. But I mean, I'm not even exaggerating. I genuinely am scared to put my hand in this blender, even though I know it's perfectly safe to do so. And it can be a lot of fun to push players' boundaries, to make them into that uncomfortable zone of what action they're expected to have to take. And you sort of think, am I really going to have to do this to get a key out? But used sensibly, obviously. Now, if you would like to access the resources for this or any of my other escape room projects that I've done on this channel, I've got those available on my Patreon account, and I'll put a link below. Do please check those out there. I've also got a Discord server where you can discuss ideas for these or all other projects I've made, or otherwise you can just leave a comment on the video below and I'll do my best to read them and get back to you. Otherwise, I just want to say thank you all very much for watching, and I look forward to seeing you next time. Okay, cheers, bye.